So beginning with problem number 2 now. Go ahead and draw yourself a little triangle of generic style. Where are we at? And you're going to label it A, B, and C. You can put your A, B, and C anywhere, as long as you fill out the triangle appropriately. So angle A is 24 degrees. Angle B is 48 degrees. And then little c across from angle C is 8.4. So we have 3 things that we still need to find. We need to find angle C. That won't be hard. Then we need to find our little a and our little b. So calculate for me, somebody, because I'm not going to pull up my calculator anymore. 180 minus 24 minus 48 real quick. How big is angle C? 108? Okay. And then label it clearly, box it in on your paper, and then also fill it in on your triangle. Now, I'm glad we found that because I was kind of stuck until we found that. The only part of my triangle that's all filled out is C. I have angle C inside C. So that's how we're going to start our proportion. The sine of 108 over 8.4 is going to be the beginning of both of our proportions. Okay, let's try to find little a first. So what goes in the numerator? Sine of 24, and then over little a. And then for this guy, we'll do b, so sine of 48 over little b. So on your calculator, 8.4 times sine of 24, and then you'll divide by sine of 108. Everyone try typing that. One more time. 3.7? 6? Okay. Alrighty. Everyone try typing it, please. And then same thing over here for our second proportion. 8.4 times sine of 48 divided by sine of 108. 6.5. Okay. Alrighty. It's very important when you set up law of sines that you guys always put an angle inside of the sine. Sometimes a common mistake is that the kids will put the leg into the sine. You would never take the sine of anything other than an angle, so don't do that. Alright, do you guys mind if we skip ahead to a different type of question? Because I think you guys can do that one fine. Yeah. Move all the way until number 8. I know we're jumping quite a bit, but go to number 8. Label it A, B, and C, generic little triangle anywhere. And this time they tell us angle A is 36 degrees, and then little a is 8, and little b is 5. Why is this different? They only gave you one angle this time. So unfortunately, we don't have that first easy step of 180 minus the 2 angles because we don't know 2 angles. So we actually have to jump straight into law of sines. So what part of the triangle are we all known? A, B, or C? A. So we're going to set up sine of 36 over 8, and that's going to be the beginning of both of our proportions. Alrighty. Now the only other piece of information we have is little b is 5, so that means we're going to have to use sine of b over b for the rest of the proportion to start with. Now here's where it gets a little weird. This time I don't know angle b, so what am I going to put right here? B. Good. Use the variable that it is, otherwise it gets confusing later. And then over 5. Now proportions are still going to work the same way. You look for the diagonal that has no variable. So we're going to start actually with this diagonal this time. You're going to multiply sine 36 times 5. And then number 8 off to the corner there, you're going to divide by 8. And you're going to have a teeny tiny decimal on your calculator. What do I still have left on my setup? I still have sine of angle B. How do you undo a sine? Inverse sine. Good. So let's see. I can pull up my calculator for this. Maybe. So you did 5 times sine 36. You can divide all in the same step. Divide by 8. And then right here, second sine, after you hit enter, And then instead of typing in the little decimal, if you do second and then the negative symbol, it'll bring up the decimal for you. It's bad to round off anything on these problems because your answer is going to come out kind of wrong. Yes, sir?
How come you use the second?
Because we had to undo the sine. Anytime you have to find an angle, you have to do inverse sine. So the problems before this, we were finding legs, so we didn't have to do second sine. Okay, so that's a good point. Anytime you're trying to find an angle using any sort of trig, you always have to do second sine, or in some other case, possibly second cosine. You hit the second button, and then the negative symbol will bring up the answer. So who did we just find? I forgot. Angle B. So angle B is 21.6. There's my answer for that. I'm going to go back to my picture and label that. Okay, now I think I can find the third angle really easily. 180 minus 36 minus 21.6. 122.4. So off to the side somewhere, angle C is 122.4. Okay. And now the last thing I need to find is side C. So I already halfway set up my law of sines proportion. In order to find side C, this time I know angle C, so it'd be sine of, I'm running out of room, 122.4 divided by little c. This time I'm not finding an angle, I'm finding a leg. So this will be a what, two-stepper or three-stepper? If I'm finding a leg, it looks like it's a two-stepper. You just multiply these together and then divide by that. So how big is little c? Okay, very nice. Okie dokie. So a little different. Sometimes you're given different types of information, so you gotta be careful. Let's do number 10. I'm gonna skip to number 10. A, B, and C. Angle B is 34 degrees. Little a is 20, and little b is 25. So again, this is the kind where I only have one angle, so I'm not going to be able to find an angle easily yet. I have to jump straight into law of sines. So who do I know everything about, A, B, or C? B. So we're going to set up our proportion to say sine of 34 over 25, and that can begin both of my proportions. Okay, there's only one more piece of information in this problem right now, and that's side A. So I'm going to have to set up the rest of this first proportion to say sine of A, because I don't know the angle, over 20. Now since I'm finding angle A, is this going to take me 2 steps or 3 steps on my calculator? 3. Multiply those, divide by 25, hit enter, and then at the very end, you're going to have to do the inverse sine of the answer. I heard 26.6. Everyone try typing that, please. Make sure you do get that answer. Okay, so I did law of sines once. Now I can do a quick, easy 8th grade step where I do 180 minus the 2 angles I know. Good. And I heard 119.4. Okay, and now for side C, I gotta do law of sines again. So on every problem, if you've noticed, you've done 2 law of sines proportions and then 1 quick, easy subtract from 180 problem. And that's how all of law of sines will go if you have to find every part of the triangle. Sometimes you guys will get to a problem where I just ask you for, like in this case, I could have just said find angle A and then stop. That would have been nice, but I didn't. But I could theoretically ask that. So sine of 119.4 over C. Is this going to be a 2-step or a 3-step on your calculator? 2-step. You just multiply these together and divide. Because we're finding a leg. How big is little c? One more time? 39.0? Okay. Okay, someone else said 38.9. So again, could be a rounding off your decimal issue. So as long as we're in the ballpark, we're good. Okay. Let's go back to number 11, or let's go to number 11. The reason I said back is because it's like one of the earlier ones we did. Since we started recording a little late into the lesson, we got to go back and do one. We're recording live today, folks. Say hi to everybody. It's not just you people who watch these videos, you know. I've got fans in other places. All right. I'm pretty popular. All right, A is 65 degrees, B is 80 degrees, and then little a is 17. Okay. I don't know if we want to call this easier, but if I had to pick two different versions of law of sines, I guess I prefer this kind of a problem. It's slightly easier. We can start by just finding this angle. 180 minus 65 minus 80. 35, I heard. So somewhere on your paper, angle C is 35 degrees. And now I'm going to set up law of sines. The start of my proportion is going to be the part that's all filled out. So for this triangle, it's going to be A. So sine of 65 over 17 is the start to both of my proportions. Someone last hour asked me, well, can I just find this proportion and then use something else to start my next proportion? My answer was yes, but I suggested they not do that because if you screw up on your finding of this, you've kind of shot yourself in the foot over here, because you might be doing the math all correct, but if you're working with a faulty number, you're not doing so well. So continue. We need to find little c and we need to find little b. So I don't care which one you find first. I like to go alphabetically, so I'm going to find b first. So sine of 80, which is b, over little b. And then for c, you'll do sine of, we found that to be 35, I believe, over c. So 17 times sine of 180, no, not 180, sine of 80, divided by sine of 65. I noticed last hour some kids got in a habit of forgetting to type the sine. They just wrote 65 instead of sine of 65. So can someone tell me what you got for b? 18.4. And then similarly here, 17 times the sine of 35 this time, divided by the sine of 65. 10.8? All right, nice job. Let's move ahead to the applications, because that's the good stuff. All right. So we kind of talked about this on yesterday's lesson, but there are surveyors. And the people who are on the side of the road, you ever see them and they look like they're looking through the cameras? They're really surveying. So they're doing what's called indirect measurement. The reason they don't throw a tape measure across the highway is because they don't want to be killed. So they use surveying equipment to measure either distances across roads, sometimes across lakes, canyons, ravines, heights of things. They are surveying. So they have special equipment that will measure angles. So they'll look at one item, they'll look at another item, and the machine, it's really like a protractor, will measure the angle in between them. A lot of surveying is just physically walking from one place to another and measuring the distance. So this particular surveyor wants to know how wide a gorge is, and it's apparently a very scary gorge. He does not want to fall in. So he's going to use indirect measurement to find how wide this gorge is. A gorge is like, the Grand Canyon would technically be a gorge. So apparently this one is very narrow, but it's very, very deep. And like I said, he doesn't want to fall in. So he wants to find the width. Right here would be the width of the gorge. So put your X on that part of the triangle. We know we're going to use law of sines because this is the law of sines lesson, but as we look at the information we have, we're going to see we're going to have to use law of sines in a second. He was able to measure that this angle right here was 10 degrees, and then he knows this is 105 degrees. Anyone know how he knows that angle? What he probably did was measured this teeny tiny angle from his shore, it's not really a shore, but the edge of the gorge to this guy, and he probably measured that to be 15. How do I know that? What angle would it be from here to here? A right angle. So if this is 15 and this is 90, voila, he's got 105. So he didn't like get out his protractor and throw a rock across the gorge. It doesn't work that way. All right, he knows from here to here is 50 because he could walk with his legs to measure that. It was 50 feet. And from here we have to solve. So remember, law of sines starts with the part of the triangle that's all filled out. So the side and the angle across from it. I think we're going to have to do a little bit of a calculation. Why? I actually need this angle up here. Isn't he the one who's across from 50? And then I heard that angle is 65. You guys got that quickly just by doing 180 minus 10 minus 105. So now we can set up law of sine. So sine of 65 over 50, that's the side that's across from him. Since I want to know x, which angle should I work from? 10, I heard. So sine of 10 over x. This is a two-stepper on your calculator. 50 times the sine of 10, and then you'll divide by the sine of 65. Apparently this is 9.6 feet wide. I think he could have just used a big stick to measure that, but whatever. You know, he's a chicken. Okay, so you're a billionaire and you're flying in your private plane and you want to know how big this island is that you want to buy, apparently. So, of course, we're going to use indirect measurement to figure that out. Maybe you can't land on this island. So, do you see two angles of depression? I see this angle right here, which is apparently 27 degrees. And then I see this angle right here, which is 39 degrees. Unfortunately, I don't think either one of those angles is even in my triangle. Anyone have an idea? Okay, we heard subtract them. So 39 minus 27 gives us 12. This teeny tiny angle right here is a 12-degree angle. He is in my triangle. He's going to be helpful. Now I think one of these angles, either the red or the green angle, also shows up down here. Anyone want to take a stab at which one? The green one, the 27. Why? Yeah. Yep. So the 27 degrees down here is because of alternate interior angles. Yes. Now what bothers me about this picture is we have a very skewed triangle. It's very obtuse. So I'm going to redraw it and I'm going to make it a little less exaggerated. Oh, that's ugly. But pretend. So this is the W down here. This is 27 degrees at this corner. This is 12 degrees up in this corner. And then the only other thing they told me was it was 1,200 feet from the plane down to the first edge of the island. So we're going to start law of sines with the part of the triangle that we know everything about. Looks like the 12 or the 27 and the 1,200 is how we can start law of sines. And then I want to know W, and I happen to know the angle across from him, so I think we're in business. That'd be the sine of 12 over W. So on your calculator, 1,200 times the sine of 12, and then divide by the sine of 27. How big is this island? One more time. Okay. Concur? Did anyone else try typing it in? Okay. Thank you. Well, that is law of sines.